Welcome to lesson 4.1, coordinates and scatter plots. So all of chapter 4 is going to be looking at the idea of graphing linear equations and functions. So lesson 4.1 is laying the foundation for our ability to do this graphing. So a coordinate plane is the first vocabulary term we'll be working with, and it is formed by two real number lines that intersect at a right angle. So this over here, this whole figure, is referred to as a coordinate plane. The two lines are special lines when they form a coordinate plane. The horizontal line forms the x-axis. So our horizontal number line is the x-axis. The vertical number line is the y-axis. And then we have a special point known as the origin. And the origin is where the two lines intersect, or point 0, 0. So the coordinates of the origin are 0, 0. This point right here where the two lines intersect. And then we have quadrants. And a quadrant is 1/4 of the coordinate plane. So each of these four sections, 1, 2, 3, and 4, are the quadrants. Our quadrants are numbered counterclockwise. So number 1's in the upper right, 2 in the upper left, 3 in the bottom left, 4 in the bottom right. And then the last term that we're going to look at to begin with is an ordered pair. So your coordinates, the points, are given in what's called an ordered pair, which gives your x value first and the y value second. So the x coordinate always comes first, y coordinate always comes second. The first number, which is the x-coordinate, tells you how far to move right or left from the origin. So you're always starting at the origin. First number, positive, means we go right. Negative means we go left. And then the second number, the y-coordinate, tells us how high up or down to go. So x-coordinate tells us right or left. And then from that point, the y-coordinate tells us up or down. So looking at this idea, example 1, plotting points in a coordinate plane. So parts A, B, and C want us to plot points A at -2, 3, B at 3, -4, and C at 0, -2. So again, if we always start at the origin, the coordinates tell us what to do. So -2, 3 means we go left 2, then up 3. So from the origin, left 2, up 3, there's point A. Point B, +3, -4, means we go right 3, then down 4. So right 3 from the origin, down 4. And then C, 0, -2, we go left or right 0, down 2. So then plot each point in the same coordinate plane. So just some more practice here. Plotting points A, B, C, and D. So A being a -3, -2, we go left 3, down 2. B being a +4, 0, we go right 4, up 0. C, 1, 4, right 1, up 4. And D, -3, 2, left 3, up 2. So now we're going to look at the idea of graphing points to create what's known as a scatter plot. And a scatter plot is simply the data plotted into a quadrant or the four quadrants of a coordinate plane. So if we look at this grid here, or this table here, we have the number of NCAA men's college basketball teams shown in the table. So the year and the number of teams. So the top row, the year, is going to be our X values. The bottom row, teams, will be our Y values. So to draw the scatter plot of the data, again, we want to title our graph. So the number NCAA boys basketball teams. Teams are along the y-axis. Years are along the x-axis. So for the years, you can see I just spaced them equally with one space in between. For the teams, I started at 800. So I jumped from 0 to 800. And then I went by tens. And then plotting the data. So for 1995, 868 teams. So for the year 1995, go up to 868. For 1996, 872. So we go over to 1996, up to 872. 1997, 881. So over to 97, up to 881, and so on for your last few points. Describe the pattern that we see in the scatter plot. So in a scatter plot, we can't connect the points with a straight line and hit every point. But we could put in kind of what we could describe as an invisible line, which you'll see in later sections is known as a line of best fit. And it would kind of start here and trend upward in this pattern. So if we wanted to describe the pattern of the number of men's basketball teams, the number of teams was increasing each year, but the growth wasn't at the same rate, meaning we could not connect it with a straight line. If the growth was at the same rate, we would have a line to connect all the points. So it was growing each year, but at different rates. You can ignore the pages and practice numbers down here. Do the ones that are listed in Google Classroom, please.